Hello there, this is Dixon from MathsWiz, where we teach mathematics and mathematical sciences. Welcome for this lesson. This is our second lesson in the series, Chemical Equations. In this lesson, we're going to learn balancing of chemical equations. Balancing chemical equations is a process of making all the atoms of the same type present in the chemical equation are equal in number on the right-hand side, that is the product side, and the left-hand side, that is the reactant side of a given chemical equation. In example number 1, let us balance the chemical equation given below. We are going to carry this process as follows. Now we count the number of atoms present on each of the side and we balance them. To start with, we start with the carbon. Carbon on this side is equals to 1. And on the product side, carbon is equals to 1, meaning that carbon is balanced as at that. Hydrogen on this side, the hydrogens are equals to 4, whereas on the product side, the hydrogens are equals to 2. Whereas the oxygen on the reactant side, they are equals to 2, while oxygen on the product side are equals to 3. We start by balancing hydrogen on each of the sides. This side hydrogens are equals to 4. This side hydrogens are equals to 2. We can multiply these hydrogens by 2 to make a total of this side to be 4. And if we do so on the equation, we also multiply the whole by 2. Realize that we cannot multiply the hydrogen only by 2 because this is already a compact chemical formula. Having multiplied by 2 on that side, it will have made now the oxygens to be equals to, this is 2 plus 2, the oxygens are equals to 4. And on the other side, the oxygens are equals to 2. I can make now the oxygens to be equals to 4 also by multiplying this side by 2. And this will give me a 4. And if I do so, I'll come to the molecule of oxygen and multiply them by 2 here. And now our equation is balanced. We now balance the second equation. We note the atoms that are present on each of the sides. We have lead occurring on both sides. After lead, we have nitrogen. After nitrogen, we have oxygen occurring on each of the sides. Lead on the two sides is equals to 1. Nitrogens are equals to 1 multiplied by 2. Whereas the product side, the nitrogen is equals to 1. The oxygen on the left hand side, the oxygens are equals to 4 multiplied by 2, that will give me 8. Whereas the product side, the oxygen are equals to 5. Realize that oxygen is the only unbalanced species, and we have a deficit of 1 on the product side. We can argue the following. The one that is remaining here, we can represent it as a fraction in the following. From the 2 that are here, we can change this one from 2 to become 3. In that we can say 3 over 2 multiplied by 2. This one will give me a 3. If I come here and multiply this one by 3 over 2, the oxygens become 3 here, plus 4. That is 7 plus 1, which now make them to be equals to 8. Our next note, in a balancing chemical equation, we do not accommodate the fractions. So given that, we can argue, we multiply all particles present in this equation by 2. So that will remove the fraction, and that will give us, we have by 2 here, by 2 we have 2 here, by 2 this becomes a 4, and 3 over 2 by 2, that gives me a 3, and hence our equation is balanced. In our example, on the reactant side we have nitrogen, and the nitrogens are 2, hydrogens are 2. Whereas on the product side, nitrogen is equals to 1 and hydrogen is equals to 3. Hydrogens are 2 on reactant side and 3 on the product side. For 2 and 3, we can use the idea of least common multiple, where we get the least common multiple of 2 and 3 is 6. So therefore, we make this one 6 by multiplying by 3 on this side, and this side we multiply by 2, meaning that we have here a 3 and here we have a 2. If we do so, the nitrogen on the product side become 2, implying that our equation is balanced. This is Dickson again from MathWiz. We hope you have enjoyed our today's lesson. Remember to subscribe to our channel and also give this video a thumbs up. Thank you for your watching.